We'll start today by refreshing the last stuff that we worked on, the for 2-day one. We are going to go through and do those half angles. And another thing that can happen, number 6, is actually kind of a nice one. Sometimes, because I'm looking for the cosine half angle, I picked the cosine half angle formula. But sometimes they give me the information and I don't even need to draw a triangle. That doesn't always happen, but it can happen. So if I have this given and I need that, the cosine, I can just jump right into plus or minus the square root of 1 minus 5 over 13 over 2. They're gonna, they give me that it's in the third quadrant, but because this is given the cosine and the cosine is negative in the third quadrant, it'll already be given there. I don't need to worry about thinking, is that sign right? What should the sign be? I don't need to change it or anything. I need cosine. They gave me cosine. They gave me the right sign for cosine, so I put it right in. And then I'll do my simplifying. And again, this is just you sort of doing the math. And however you need to work through your fractions. I believe that is 13 minus 5, 8. Yep, okay. So then I would do plus or minus 2 over the square root of 13, or plus or minus 2 times the square root of 13 over 13. And then lastly, I have to pick my sign. So I still need to consider where I'm going to land with the half angle. So remember that whole process where we take where we started and I divide everything by 2. So I'm from pi less than theta less than 3 pi over 2. Actually, it's less than or equal to. On that first one, I cut everything in half. And figure out where I am between pi over 2. My camera, sorry. Between pi over 2. Start here, go up to pi over 2 and 3 pi over 4, so that puts me in the second quadrant. Second quadrant is negative, comma, positive. I am finding the cosine half angle, therefore I'm interested in the cosine, so I can scribble out the positive to get my final answer. Final answer, negative 2 times the square root of 13 over 13. Today's material is going to kind of work through it the same way. We are going to use double angle formulas. But what's nice about the double angle formulas is they're easier, because this last step, remember this process where if I have this radical and it's plus or minus, I have to figure out what the sign is. Remember, tangent didn't require us to do that if we used one of the second, like the formulas without the radicals on it. Well, all of the double angle formulas are without the radicals. In fact, here are our double angle formulas. If you want to take a few moments to get those written down, I left some extra spaces because there are variations of the formulas that we can use as well. And so one of them is using the identity from our yellow chapter, from the last chapter. The fact that cosine squared plus sine squared equaled 1, we could replace sine squared with 1 minus cosine squared. That was one of those identity options. When I do that, I can combine this, I distribute the negative, so I could do a variation that gives me 2 cosine squared theta minus 1, and then likewise I could do another variation where I'd replace cosine squared with 1 minus sine squared and simplify it, so this would be 1 minus 2 sine squared theta. Now, just like the tangent half angle, you can use any one of these. No matter which one you use, they'll come out to the exact same answer if you do your math right. And so it doesn't matter. Use the one that works for the situation that you have. Okay, so those are the formulas that we're going to be using today. Again, pause it, get those written down, and then we're going to move on. You'll find, like I said, these come out a little bit nicer. You might need to use those Pythagorean triples. If you don't have them handy, remember you can always use the Pythagorean theorem. But on this first one, I'm using the cosine, or I'm finding the cosine double angle, and I'm given the sign. So cosine double angle given the sine would mean for me that I would probably want to use the one that has only the sine in it. Then I don't even have to draw a triangle. So that formula is 1 minus 2 sine squared theta. That just means I do 1 minus 2 times whatever the sine is and square it. The sine is 15/17. So I have to square those values. Again, use your calculator to do that. I'm going to do 1 minus 2 times parenthesis 15 fraction 17 end parenthesis squared. Make sure you put the square after the parenthesis. And when I hit enter, it should give me my value. I got negative 161 over 289. Final answer. I don't have to think about the sign. It'll work its way through the sign. You just, again, have to pick the right formula and plug it in. Like I said, there are going to be instances where I maybe have to draw the triangle. And if I chose on that first one to use either one of the other two formulas, I would have had to draw the triangle to find them. That's why I chose the last one. So up next is tangent double angle. So I pick my formula, 2 tangent theta over 1 minus tangent squared theta. This time I'm given the sine, so I definitely need to draw my triangle. I need the tangent. I'm given the sine. I am here in the third quadrant. That's important. Between pi and 3 pi over 2 is the third quadrant, which means there's a negative sign and a negative cosine, but when I put the sine over the cosine, it'll be a positive tangent. So my tangent is going to be positive. So I'm not going to worry about the negative when I set up my triangle. Opposite over hypotenuse. This is one that we did when we did our half angles. That's a 3, 4, 5 family, very popular one. So I knew the 3 right away without having to do the Pythagorean theorem. So my tangent in the third quadrant is positive, and I put the opposite over the adjacent. And now I can plug this in. This is 2 times 4/3 over 1 minus 4/3 squared. And again, use your calculator or do it by hand, however you need to do this. I get 8/3 over negative 7/9. And again, 8 fraction 3 divided by negative 7 fraction 9, and I'll get my final answer. I always like to put it in improper form, so negative 24/7 is my final answer. All the signs are taken care of. Again, I don't need to worry about figuring out what the end result is. It will work its way through. Double angle are easier than the half angle for sure. We'll do a few more examples. In fact, we'll do 3 more, and then I'll leave the last one to refresh when we return again the following day to make sure that we kind of got it all and we're all on the same page. So our goal again, or our start here, is pick the right formula. This is one of those tricky ones where it is not a normal looking fraction. I've got a radical in it. It's not one of those Pythagorean triples. So when I draw my triangle, because I'm given sine, I need to find cosine. I will put the square root of 3 as the opposite. The hypotenuse is 6, and I do the square root of 3 squared plus x squared equals 6 squared. So I get 3 plus x squared equals 36. So x squared is 33. X is the square root of 33. Kind of another ugly value. But when I set up to find my cosine here, my cosine of theta is the adjacent over the hypotenuse. I'm just going to leave that in. It's fine. But I do have to remember where I am here. Between 3 pi over 2 and 2 pi, that's the fourth quadrant. The cosine is positive, the sine is negative, so my cosine is going to be positive when I plug it into that formula. This is 2 times negative square root of 3 over 6, they gave me that value, times the square root of 33 over 6, and now I just have to figure that out. Problem is, most of your calculators aren't going to be able to deal with that. They won't work with that, so I want to do this one kind of by hand here. This is going to be negative 2 times the square root of 99 over 36. I just multiplied everything on the top. 2 is over 1. And then I will start to simplify. This is negative square root of 99 over 18. And the square root of 99, some of your calculators are nice and they will simplify that for you. But way back in the beginning, we did some simplifying radicals. I have to take 99 and break it down. You want to pull out as many perfect squares as you can. I usually start by dividing by the smallest number, and then I just keep doing repeated division until I can't divide anymore. For every pair I have, one goes out, and then whatever is left stays in. So this is negative 3 times the square root of 11 all over 18. And then I can simplify that one more time. So my final answer is negative square root of 11 over 6. A little bit of a process there, but just simplify the radicals, follow the rules. If you have one of those nice calculators, it'll kind of work through that for you. If you don't, sorry, then you have to remember how to do the math. A lot of these won't show up. You won't see a ton of them. You'll see more of the families, but I do want to show you that occasionally you are going to get some kind of funky stuff that isn't going to come out nice, so just be aware of that. And up next, cosine double angle. That was one where I can pick any one I want. This one gives me the sine, so again I'm going to use the sine one. So I'll use 1 minus 2 times the sine squared theta. Then I have less work. This last one, number 9, was a lot of work. Number 10, much less work. Plug that in, negative 4/5 squared. And again, if I have my calculator, and most calculators can handle this kind of stuff. They can't handle these radicals, but they can handle fractions with negatives. I do 1 minus 2 times negative 4 fraction 5, end parenthesis. Again, please make sure you put the squared on the outside of the parenthesis, and it'll give me my value, negative 7/25. Final answer. One more, and then I'll let you go on your own and do your practice. And then again, we'll revisit that last one just to make sure everybody's okay when we meet again the next day. So cosine is negative 3/5. I'm interested in the tangent, so I have to use the tangent formula. That is 2 tangent theta over 1 minus tangent squared theta. They gave me cosine. I'll draw my triangle. Adjacent over hypotenuse is the cosine, so the missing one is 4. This here is between pi and 3 pi over 2. That's in the third quadrant. Again, this is an instance where both sine and cosine are negative, but in the third quadrant, tangent is positive. So when I pick my tangent, it's going to be a positive value, which is opposite over adjacent. So I have 2 times 4/3 over 1 minus 4/3 squared. Oh, that looks like the exact same problem as the last one, or very similar to that one. And so I remember it ended up being the same. It was the same. They just gave me a different value and the same angle. So I know the answer on that one. Negative 24/7 is my final. Again, you can plug it in your calculator. If you use your calculator to do this, I recommend that you find the top, find the bottom, and then do your division. So good luck with that all. Please do your homework on section 4 to day 2.